The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
The Metis Tech Show.
All right, so I went out to eat with my wife a few weeks ago, actually last month. It was right around Cinco de Mayo. So this restaurant, the menu was all, pretty much around food from Cinco de Mayo. So I saw something on the menu that I see on TikTok videos, see it on Instagram, Facebook, and my kid has been going crazy. Like, Dad, can you make these tacos? They look awesome. And they're called birria tacos. And I don't know if I'm pronouncing that right, Sergio, but
you got to roll your R a little bit more.
Yeah, birria tacos. So it was like the best dinner / lunch, whatever it was, that I've had in a long time. I enjoyed that so much. It was 3 tacos, and I think they're corn shells, but they're soaked in this birria sauce or juice or whatever you want to call it. They give you a little cup so you can take the taco and dip it in there as you're going along. It had short rib in it and mozzarella, and I think you can put whatever you want in these tacos for meat, and probably carnitas or chorizo or whatever. But what do you see, Sergio, for most common?
Typically, what they use, the birria came from, they use it for like weddings and stuff because it's easy to make and you can make a whole lot of it for not a lot of money. They typically use chuck roast, but with the braised rib, that's probably good too. But you don't need a very expensive cut of meat, and it's got a bunch of chilies in there, like guajillo chili, ancho chile, chile de árbol. The chile de árbol, that's a spicy one. So you guys can kick it up as much as you want, make it as hot as you guys want it and stuff. And then that marinade that you're talking about, it's just the juices from the meats.
Yeah, don't they like they make the taco and then they dip it into the sauce and then they put it like on a skillet, whatever, and cook the taco that way, right?
Yeah, because that kind of hardens up tortilla so it doesn't fall apart.
Yeah.
Yeah, so they also serve it to you in bowls because like that consomme is very tasty too. So then you can just eat it with the bowl and you don't have to just necessarily have it with tortillas. Just kind of like a stew.
So is basically the biggest difference that it's just the stewed meat, it's slow cooked and braised in its own liquid, and then it just falls off the bone, melt in your mouth. So it doesn't have to.
Yes, exactly.
Because you can slow cook anything and it's going to be tender than not.
Yeah, and then I've made it in a crock pot, and it comes out really, really good. And it's very simple. You just put it in there and forget about it.
Yeah, you put how do you say it? Birria. Okay,
it's that sauce, man. That's where it starts and ends. Starts and ends with that sauce.
Yeah, that sauce is amazing.
Yeah, I was blown away with the flavor, and just having that sauce there to dip that taco in was just out of this world. So what about other types of tacos that you guys have had from a restaurant or from a food truck or from whatever?
Al pastor tacos. Those are really, really good. It's pork and they cook it on a spit, and it's marinated in spices and stuff. And you typically put a pineapple on top. So as the pineapple's cooking, it coats the pork meat.
Oh man!
And they start slicing. It's on a rotisserie, so the flame's on the side, and they just start slicing the meat as it's being cooked. And then they give it a little grill just to like toast it up a little bit. Those are really good tacos.
So it's almost like a gyro. When they make a gyro, they shave that meat and it just falls right into the taco.
Mm-hmm. And guys, just a heads up, this is the difference of California Mexican food from the rest of the country, because I miss California Mexican.
Oh, yeah, it's amazing.
It's hands down. It's night and day compared to any other. Yeah, California Mexican.
Sergio,
it's not Tex-Mex, it's Cali-Mex.
Yeah. Cali, yeah.
So, Sergio, you just answered a question for me, because when I go out by you, I go to Rico's Taco El Tío, and I get the El Pastor, carne asada, and carnitos. I never really knew what El Pastor was. I just get it. And carnitas
Yes.
is pork, right?
Pork. Yes.
And carne asada is beef.
Yes.
All right. Those are the best tacos in the country, I'm telling you right now.
Yep. I heard they make special burritos just for you, Paul.
Yeah, they do.
That's what Cesar told me.
Yep.
Yeah, I love chorizo tacos too, sirs.
Those are good. Chorizo tacos are good. Yep. But you got to get good chorizo. There's some chorizo
I know.
that's nasty.
Yeah, I agree.
Yeah.
Yeah, it's been hit and miss.
There's a Portuguese company in New Bedford here, where I'm from, up in the Northeast, that specializes in Portuguese chorizo and Portuguese linguiça and sausage, and they just came out with their version of the chorizo, Mexican chorizo, and I tried it. I think they should stick to the Portuguese style.
Yeah.
It wasn't like the chorizo I've had before.
I like Salvadoranian chorizo. Salvadoranian chorizo is really good.
Who?
It's like little balls, and you can grill it, and it comes with a natural casing, so you don't have to take the casing off. And that one's really, really, really good.
Yeah, there's a difference.
It has a good spice to it.
There's a difference between Mexican and Portuguese chorizo. The way it's made, it's chunkier in some things. But so, Sergio, what was that pepper that you said was a really hot one?
Chile de árbol.
Chile. What's guajillo?
That guajillo is kind of like an Anaheim chili, or like those long peppers.
Poblano pepper.
Something like that, yeah.
Mm. We all know Steve likes the shuri queso when it comes to chorizo.
Oh, yeah.
Put it on the
I was just going to say that. Juan introduced me to shuri queso probably like 3 or 4 years ago when I forgot where we were. And I said, Juan, ask for that cheese sauce stuff. And he's like, it's called queso. And he's like, do you want the shuri queso? And I was like, what's that? And he says, well, it's chorizo in the queso. I'm like, oh, dude, yeah, you'll order that up. So he ordered it. The guy kind of gave him a look like, that's not on our menu, but I got you covered. And they just come out with this little dish, and it's that liquid cheese dip, but they put crumbled chorizo in it, and that changed my life. From
that's
then
good.
on.
It changed your outlook on Mexican food, didn't it?
Yeah, and then I got a restaurant that I go to with my wife and kids up the street, and I asked the waiter, I says, hey, you guys have shuri queso? And then he looked behind him and looked around the room, and he said,
no, our queso's pretty good.
I can hook you up. I can take care of you. So he came out. They did a good job getting me there, but it's not something that's commonly on the menu.
Steve orders off menu.
Yes, that's important.
Yep.
All right, well, welcome to the Metis Tech Show, everybody. Steve Pimentel here, technical instructor out of Boston. We got Bryn Raptor,
Hey, how's it going?
instructor out of Boston as well. Scott Tallman out of Suwanee, Georgia.
Hey, guys.
Paul Shaves, senior training manager for Metis. Everybody knows Paul.
Hey, not really.
And we got
I don't know.
a new voice.
First time joining us, Sergio.
Yes, Sergio Cuder out of L.A. He's on the West Coast. What time is it there, Sergio?
It is 11:33.
It's morning for you.
Hello, everybody.
So we're going to talk about what are the most common mistakes in heat pump installations and how do you avoid them? Right now, we got basically 4 main topics that we're going to cover that we think are going to make or break your heat pump installation.
Yep.
And we're going to stick to residential, but some of this can kind of fold over into commercial as well.
I think most of it can, actually. So
Yeah. So what can go wrong, and how do we avoid these things, right? How are we going to make this heat pump last 20 years, 30 years, right? How are we going to make sure it's performing at its highest efficiency, right? So I think number one is going to be not performing an accurate load calculation and improper sizing of ductwork.
yeah, let's
Right.
take those one at a time.
Checking
because they're-
static pressure.
yeah, they're both
right?
important. Sorry, Steve, I stepped on you. I didn't think we were going to go through the topics.
Yeah, and I'm used to it. Don't worry. You step on me all the time. So Let's talk about not performing an accurate load calculation. Bryn, bring us into that.
Yeah. So obviously, when we're talking about load calculations, there's a lot that goes into it. It's not just a matter of, well, realistically, it's not like the old school where they count the windows, they do a square footage of the room, and they make an estimate. I mean, a real load calculation, you're taking into account what type of windows, how many, how large the windows are, what kind of insulation is behind the wall, how thick your sheetrock is, what type of siding is being used. There's a lot that goes into a proper load calculation.
Even the color of the roof makes a difference. Which way is the house facing? Is it facing north, south, east, or west?
Yep.
So all those things. And most building codes require an ACA-approved method of load calculation.
Mm-hmm. Yeah, I mean, in my case at my house, our load calculation was way off because the insulation in the attic was upside down. That changes things.
It changes the vapor barrier.
Yep. So yeah, I mean, you got to pay attention to it. Obviously, Manual J is what the kind of the standard is as far as doing a load calculation. And I think we've had podcasts in the past about different softwares now that are available for doing load calculations. So there's no shortage of information. There's no reason why you can't do a proper load calculation. And then as it relates even to our stuff, if you have an improper load calculation and you bring that to something like our Diamond System Builder, you're going to size equipment improperly because you're going to be sizing for an improper amount of BTUs for that load.
And I just want to say, when we talk about load calculations, so we don't ourselves teach load calculations. There are other organizations that do that. But it's just getting, with the technology we have today, it's just getting easier and easier to get them done. When I was going to school a long time ago, we had to do load calculations on paper. And I mean, this sheet of paper, if you put them all together end to end, is probably 1.5 miles long. And there's all kinds of things you had to do. It would take you half a day to do a load calculation on a house, maybe.
If you're doing it right.
And then they got software, different software. RightSoft is the one I think it's, at least from my experience, was very popular. And there's a new one I just heard about recently. It just got approved by ACA. It's called Conduit.
Yep.
Where you use an iPad and you actually just scan the room and it measures the room for you. You put a few things in there. It knows where the windows and the doors are. So it's just getting easier and easier to do load calculations. So there's no excuse for not doing them. And I know, Steve, we were talking earlier, but a lot of times, and when I first started working for Mitsubishi, I'd hear this a lot from contractors. Oh, you got inverter compressors. They're variable speed. So they're forgiving. You don't have to do a load calculation. So is that true?
That's definitely wrong. And it's when mini splits first came out with inverter technology, everybody thought, well, I can take this 5-ton system and not worry about it being oversized for this living room and just cool the hell out of it, heat the hell out of it, and it'll just speed down, it'll ramp down and maintain capacity. Yes, we do have capacity control, but it's not like you think it is, and we're not going to be able to dial in that perfect BTU for that space or spaces in that house. So you got to be really careful we don't end up with a cold, clammy house in the summer and something that's overheating. And this is especially true with multi-zone systems, whether it's a branch box or a ported MXZ system. We really have to be careful with oversizing at that point because those other indoor units will always have some refrigerant flowing through them. So that'll cause some issues in that space, overheating and whatnot.
Yeah, and a situation I hear about quite a bit is they have a small room, the house is tight, it's new construction, it's well insulated. They only need 3,000 BTUs, but they're going to get the smallest unit we have, which is 6,000, and then, that's probably going to overshoot a little bit because you're oversizing for that room. So you got to keep that in mind.
Yeah, I think Steve nailed it on the head. One of the biggest downfalls to oversizing is, dehumidification is a byproduct of, air conditioning. But if you're driving down that temperature really quick because you've got an oversized indoor unit, you're going to end up not pulling enough moisture out of the air. So you're still going to end up with comfort issues, even if you're driving that temperature down because not enough humidity has been pulled from the room.
Yeah, it's cold and clammy. In the wintertime, and if you're in the heat mode, it's going to be like you're going to be hot and you're going to be cold. You're going to be hot, you're going to be cold. It's just going to be, it's going to go crazy. So it's about comfort. So absolutely, load calculations are required. If not by code, And I think they are in most states, if not all the states. But yeah, you need to do it. You can't just skip it.
Yeah. And I don't know a single motor that enjoys and has an extended life when you're short cycling it.
Yeah.
Whether it's your fan or your compressor motor.
Right.
Yeah.
Short cycling that thing because it can drive temperatures so quickly, it's not great for the motor.
Not for any motor. I'm going to digress because now you got me going on my car with the auto shut off. You know, you have to, every time you start the car, you got to shut it off. The most wear and tear on the motor is when it starts up. You know, but they think they're saving gas. I'm not going there.
Hate that feature.
It's the first button I hit every time I start my car.
Yeah, but you should be able to hit it permanently. I'm going to write a letter to my congressman. Well, I would write a letter to my congressman, but I'm not allowed to anymore.
I drove a particular vehicle that was a rental that you actually had to go into the settings on the dash to turn it off every time. Wasn't even a button.
Tell me what kind of car that is so I don't have to rent that one ever again.
Yeah, so you never rented that car again.
Yeah, no. So not even just room, load calculations as far as sizing the room, but we also have to pay attention to ductwork, right?
Big one.
So even if we're sized properly, but then it's a ducted unit, whether it's a ceiling concealed or multi-position air handler or our IntelliHeat that goes on existing ductwork, paying attention to whether or not that ductwork is optimized for the load is also important.
Yeah, because what a common practice, I think we've talked about this before too, Brent, is a common practice is I show up, I'm going to replace an air handler or a furnace. Well, I'm taking out 100,000 BTU furnace. Well, this one's a lot more efficient, so I just need an 80. I don't look at the ductwork. I just assume it was okay. But if there were issues before, there were going to be issues. Now, you can't just – you used to be able to get away with it before, but you can't now. We need to check that ductwork. And Scott is our ductwork expert here on our team. So, Scott, what should we be doing when we show up? When we show up to size the equipment, we're doing the load calcs. We've done that part. What should we be doing as far as the ductwork's concerned?
Well, I mean, first things first, we gotta check our statics, right? Our static pressure. Because the biggest thing, Paul, you kind of nailed it on the head, right? We go in and they take out the furnace or bring in our air handler. We use an existing ductwork, which more along the lines, ductwork might be oversized, right? And just give you in theory, kind of understanding oversized ductwork, thinking about filling up a hose with completely water, and then at the other end, it's just trickling out, right? To think of that being oversized ductwork. So we need to take our external static. So since our air handlers, I'm just going to stick with the air handlers in this example. It comes with the filter installed, so we need to include that into our static measurement, right? So we take a static measurement before the return filter, and then the supply coming out of the unit. Then you take those two numbers and then seeing what our total static is for the system. So, and then from there you land it where is it at in the chart? The install manual we'll have this, and then from there if we need to speed up or slow down the unit to match our static.
Yeah. So in the old days, and I'm going to admit this here, but back in the old days, it would be pull out a ductulator, you'd measure, okay, 20 bay ductwork, everything would be 0.1 static. Everything would be done on 0.1 static. That's where we're going to go.
0.08 for the return.
Yeah. So that doesn't work.
So again, you just have to be careful on some of our units, like our SEZ, right? That's our smaller ducted model and indoor unit. And that's not it. A lot of people are saying you can't put ductwork on it or you can't put ductwork on it. It is a low static unit, ductwork, right? So you just have to make sure you're within that range for that static for that particular unit. So right. When installing our ducted models, it's always 100% to always take a static measurement.
Yeah, and not just that, but having nice round turns on your ductwork. Making sure your ductwork is sealed, right? Making sure that you're not using more than 5 feet of flex. You should be using hard pipe on a low static system like that. There's a lot of misconceptions in our trade, and especially when flex duct came out in the 80s, right? And here's a box of flex duct in 25-foot lengths. We're stretching this out. And we're sometimes connecting 2 25-foot lengths together and running it across someone's attic. And the amount of pressure loss
happens.
in that flex duct. It was meant to be used in 5-foot sections, so you could go from a piece of hard pipe to the boot in the ceiling or to the boot in the floor to make an easy connection. That's what flex was designed. That was what it was invented for. We just went nuts with the stuff, right? And we ran it everywhere and thought it was the end-all be-all solution to getting air over to a room. And there's so much pressure loss inside of that flex duct. We got to be really careful how long of a run of flex we use, and make sure it's stretched completely.
And what people don't think. Go ahead, Steve.
I want to go back a second to existing ductwork. A lot of times you may be going in and do a retrofit. That customer may have had a gas furnace, just heat all the whole time they've been living in that home, and they've never had AC. Now you're installing one of our air handlers, adding AC. They have floor registers in, and the ductwork is way oversized because a lot of it was back in the day, and they relied a lot on convection to get heat into through the floor diffuser. It wasn't so much CFM as it was convection from that furnace coming up through the floor. Having high wall returns, maybe you want to look at putting in some high wall returns and make sure you're getting that cold air now that's coming through the floor is getting picked up by a return that's up high and on a wall somewhere. And that may require using the walls as a chase or something, but getting your returns up high, right? So we have good airflow circulation in the space. Old dampers that are in that existing ductwork, right? They could have some really old dampers in that ductwork, and just leaving that in there is going to, you want to take a look at that and revisit it and make sure that number one, the ductwork sized properly, all the dampers have been updated, right? And you want to make sure if you're going to be adding cooling and it's floor diffusers to have high wall returns in there so that customer is comfortable and you're not coming back on a callback.
Well, yeah, to your point, Steve, right, to the old existing systems that are out there, they don't, typically it's 0 to 60 hertz, right? I mean, just full on, full off. With our system,
exactly, yeah.
We don't have that. We have different speeds depending on what state we're in at that particular time. So,
and that's a good point, because I've heard of installations going bad really because they show up on a job with an existing ductwork. They throw in one of our multi-position air handlers, and now they're wondering why they have less airflow than they did before, whether the ductwork's too undersized or oversized. We have to keep in mind with Mitsubishi electric heat pumps, our indoor units have thermistors on the inlet of the evaporator coil and in the outlet of the evaporator coil. So that's constantly being monitored. The amount of airflow passing over that coil, if it sees something, coil getting too cold, it's going to speed the fan up. If it sees the coil is too warm, that fan is going to be changing speed constantly. It's not like you said, Scott, where it's just on or off, high speed, medium speed, or low speed. It's a variable speed motor inside that air handler. So that brings us to dip switch settings for static pressure, right? Every indoor unit has a specific static pressure. With our P-Series P-Series style indoor units, we're able to adjust the static pressure on our ducted units, whether it's a ceiling concealed or a multi-position air handler.
Yeah, so Scott kind of touched on it, but when we're talking about checking static pressures, usually I think it's SWA and SWC. Once you take that external static, you bring it to your install manual, and you'll kind of get an idea of where to set those two dip switches depending on what you get as a calculation for your external static to make sure that we have proper airflow. And when before we move past the flex duct, because the reality is that on a lot of retros, especially I used to find in attics a lot, there was tons of flexed. How it's hung matters too. So it's not even just how much is being used, but you go into some of those attics and it's hung like crap. The hangers are actually kinking that flex duct, reducing airflow. So you might even need to, on a retro, maybe just readjust what's already there. It's not even necessarily, okay, get rid of all this flex duct. We've just changed the job entirely. but do a better job, be more thorough when it comes to making sure we have airflow to all those registers.
Yeah, but to your point, Brent, flex duct, initially it's great, but what happens over a month, months and years, that flex duct kind of goes from a 12-inch round, and now it's just kind of kinked in now to a 5-inch round. So, and that starts right there, you're restricting airflow. Yep.
And then as dust starts to build up in there, you start to consider duct cleanings, and most companies won't touch flexible duct for duct cleaning just because of the manner in which they remove that dust. Will kind of tear up that flex duct, so then they don't want to touch it. So, yeah, there's some problems with that for sure.
So you can't just...
In the last 15 to 20 years, a lot's changed with sealing duct work. Now it's required by mechanical code that you seal the ductwork with duct seal, which is huge. That makes a gigantic difference. The other thing I wanted to talk about too is filters.
Mm-hmm.
Right? The type of filter that you put in. I know there's a lot of MERV rated filters out there. The higher the MERV rating, more it's going to collect. You're going to get yourself into trouble with our low static pressure ducted units if you're putting in too high of a MERV rated filter or too thick of a filter, right? 4-inch air bear filter not recommended for a small SEZ ducted unit. You're going to have nothing coming out the other end, right? So make sure you have the right type of filter. That everything that you in there is going to contribute to that pressure drop, right? Every fitting that you put in is going to contribute to that pressure drop. Flex has got a huge pressure drop, so you may want to keep it hard pipe at that point.
And then side point, that's why it's critical to change out filters on a regular basis.
Yes.
Yep.
Yeah.
Filters? There's a filter?
Every 3-4 years, anyway.
That's when the customer says, I thought that's what the maintenance was for.
Yeah. What?
All right,
Oh,
should we
were you
move to
going
number
to add
2?
something earlier?
Yeah, but I forget what it was. I was going to talk. It was about the flex duct. I've mentioned this before, but I've seen people just open up either end of the box, connect one to the takeoff and one to the boot, and leave everything else inside the box. It's not pretty.
Stretch your flex. It's a lost practice. You got to get one guy on one end, one guy on the other, stretch it out nice and tight, get the inside of that flex duct to stretch out nice, and you'll get better airflow out of it. All right, number 2, Bryn.
So number 2 would be cross-wiring your outdoor unit and indoor units and supplying incorrect voltage or wire size. So this is all, specifically with our stuff, cross-wiring is a big problem, things to pay attention to, making sure that you're applying the proper voltage. Most of our units in the residential side are 208, 230. So if you put, 120 to it, you're going to run into some problems. Wire size, of course, when it comes to communication is a huge concern, whether you're using branch box style with MNet or you're using just your S1, S2, S3 wires for communication. The actual wire size and type is really important.
Yeah. So solid versus stranded, I found that out the hard way.
Nope.
When I was back in the field installing one of my first Mitsubishi systems for the communication wire, I just used thermostat wire because that's what I had. And after a couple of years, you go through the summers, you go through the winters, and copper expands and contracts. And that communication wire now had these little cracks in it that you could pass voltage, but not communication. So stranded wire is absolutely a requirement.
Let's start with line voltage coming into the unit. Let's start with L1 and L2 and the proper voltage, right? Because our nameplates will have a minimum and maximum voltage that unit can handle. Usually it's 187 to 253.
Yep.
So that's really important. Now, you may think to yourself, well, I don't really check the voltage. I think it's pretty normal. Well, what's normal, right? It has to fall into that range. You may be doing most of your installs in just a normal residential neighborhood where the voltage is within that range. But what if you're on an island or some specific location where that voltage is just a little bit. I mean, I hear this from contractors all the time.
It's big in like mountains in Tennessee and stuff like that. I get a lot of those guys in my classes.
Yeah, so I like Block Island off of the coast of Rhode Island up here in the Northeast. I have a lot of contractors doing jobs out there, and they tell me that the voltage is in the high 240s, creeping into the low 250s, and that could pose a problem. On the high side of that voltage, we could start experiencing board malfunctions, boards burning out, motors burning out, right? Communication faults at that high voltage. Same thing on the low end of the scale where you're down below 190 volts, under 200 volts. I want to start, I'm going to start getting a little leery about what's happening with my communication voltages. Am I going to end up coming back out for a callback because of this? So voltage plays a huge role. On the low end of the scale, you're not so much going to start seeing boards burn out or anything like that, but you're going to see a lot of communication faults, and something that you don't want to start diagnosing and go down that rabbit hole. But your multimeter is your best friend. Check your voltage no matter what install you're doing, where you are. Make sure you have a good ground. Make sure you have the correct voltage feeding that unit. And then from there, when we talk about having or possibility of cross wiring, now we're talking about our communication voltage from the outdoor unit to the indoor unit. Every manufacturer has a specific control wiring configuration, S1, S2, S3. Another manufacturer may be using something else. Mitsubishi uses S1, S2, and S3. So S1 and S2 is going to be my 208, 230, or my line voltage feed to my indoor unit to power the indoor unit. And between S2 and S3, we have our communication voltage, which is a combination of AC and DC voltage. So essentially, the outdoor unit is sending out 24 volts. The indoor unit is sending out 12 volts back to the outdoor unit. And it's just a communication that happens immediately when you flip that outdoor disconnect. That outdoor unit needs to see a return voltage come back to it saying that I'm connected to an indoor unit. I see you and you're responding, and it needs that communication. If it loses that communication at any time, that outdoor unit immediately goes into a fault. Now, when we say cross wiring, that means I'm running S1 from the outdoor unit and say I'm landing S1 on S3 at the indoor unit. How does that happen? Usually we're following color codes, right? We're following the colors of the wires. But if you're having an electrician wire this, and he may be new to Mitsubishi, he may not be 100% experienced with wiring a Mitsubishi unit, he may throw in a junction box, throw in some wire nuts, maybe cross those wires somewhere. Maybe we've wired in a condensate pump that is wired incorrectly. It's wired to our communication voltage instead of the S1 like it's supposed to be. So that's what we mean about cross wiring outdoor and indoor units.
Yeah, in cross wiring, most people, when they hear cross wiring, they think of multi-zone units. I put a indoor unit A to port A, and I put indoor unit B to port B, but then I run the wires and I cross the wires to the wrong one. I've actually seen it done with two one-to-one systems where the two outdoor units are right next to each other. One was on the indoors, one was on the first floor, one was on the second floor, and the electrician ran the wrong wires to the wrong unit, but nobody noticed until the winter time, or the fall actually, when they were using them different times. So cross-wiring, you just got to be careful. And I think when we talk about the piping, which we're going to do in a little bit, the same practices can be done with that. When you're running a wire, label it on both ends so you know where it's going to go.
Yeah. And just to take a little departure from Mitsubishi, when it comes to cross-wiring, these types of things happen in all heat pump applications. I can't tell you how many times I've seen, and maybe even did at one point myself when I was in a van, miswire a thermostat to the outdoor unit. And, with different style heat pumps, you may be having to do all of your programming through your thermostat when it does reversing from heat to cool, and when you're going to energize your electric strip as backup, and you land a wire on the wrong thing. Ask me how I know. You may end up giving that customer a $500 electric bill because a heat strip comes on every time it's in cooling.
Yeah, that's a good point. And if you're used to installing one particular brand, don't assume that that's the same configuration for every brand. Follow the unit-specific manual for that manufacturer. If you're installing Mitsubishi, go to mylinkdrive.com and download the install manual. Follow the wire size, and that's the next thing I want to talk about is wire size. Not so much on the line voltage coming in because the electrician is sizing that properly to the model tag information, breaker size, right?
Hopefully.
But I'm talking about wire size on S1, S2, and S3, your communication wiring. If that wire size has to be exact to the manual, okay, normally what we ask for on P series is 14 gauge wire, right? On M series 1-to-1s, 14 gauge wire. And basically for MXZ branch box type, a little bit different because now we have MNet shielded wire. Make sure you're using the right wire from the outdoor unit to the branch controller for your MNet. Wire size is hugely important when it comes to communication, because the electrician may be inclined to install 12 gauge on everything with 208. He's just going to be skeptical and say, well, this is a 208 indoor unit. I'm running 12 gauge wire. And already you're going over the wire size recommended. If it's asking for 14 gauge, make sure you're running 14 gauge. What's the big difference? Why does it matter? Well, larger wire, more surface for that communication voltage to travel on, and more of a chance of slowing the communication down with larger wire, causing communication faults. And it's no fun to be a technician trying to diagnose why you're getting intermittent communication faults. And when I say intermittent, you may be going out to that customer's house once a year to reset their disconnect. Why? Why is there a communication fault? There's something you're going to have a hard time finding after the fact. So make sure that all of this is nailed down on day one of installation, correct wire size, that you minimize the amount of wire nuts and connections on your communication wiring, and that's going to save you from going out on those callbacks.
Yeah, another thing that was discussed, I know in a previous podcast, was we talked about, third-party condensate pumps or float switches where you may see in the manual, particularly condensate pumps, the manual of those pumps may say to break S3. But we don't want to see S3 broken, even if those it's wired perfectly. The contacts inside those switches and those condensate pumps are not as they can weaken over time, and that's where that communication. We have this binary code that's passing through S2 and S3, and going through those contacts can affect that communication, which is why we always want to see S1 broken, because power can travel through those contacts much easier. That's a dedicated power wire. S3 is a dedicated communication wire. We don't want to see that broken by anything, ideally.
Yeah, because those contacts in that switch, they'll pass voltage, but they won't pass communication, which is, again, not to beat a dead horse.
All right, that brings us to number 3 on this list of things that could make or break your heat pump installation. Failure to keep your system piping tight, clean, and dry. Right? To me, the piping is the lifeline of that system. Right? So right from the get-go, we got to make sure that we're keeping all of that piping moisture-free, debris-free. Right? We all know moisture, what it does to oil. Turns it acidic. Acid is bad inside of a compressor. It deteriorates the winding varnish, and you end up with a burnout. Now, on a residential system, and I talked to you about this the other day, Scott.
Yeah.
What do you do if you have a bad burnout on a residential outdoor unit? That was a really good question, because on the commercial side, we have a filter manifold that we can install and kind of clean the system up. There's a procedure for it and everything else. But we don't really have anything for the residential side. And I think the biggest reason is all of the strainers that are involved in a residential unit and an outdoor unit. You could see up to 6 or 7 strainers sometimes in an outdoor unit alone, not counting the branch controller and the indoor units that have strainers in them or could have strainers in them. And you have a really muddy, sludgy burnout on that compressor. what happened to all those strainers and what state are they in at that point? You're going to go in and cut all those out. It sounds like a labor nightmare to me at that point. Your best bet at that point is to replace the outdoor unit altogether. But again, it all depends on the type of burnout that you're dealing with on that. So from day one of the installation, keeping that system dry is paramount. You agree?
So yeah, even if you have issues with a burnout and you need to potentially replace the outdoor unit, before you do that, it's always a good idea to maybe do an acid test. There are flush kits and things like that. I know there are some things out there now that are actually mechanical pipe cleaners where you actually send, they call it a plug or a pig something. You can actually send it through the piping in the indoor units to help clean up the inside. So there are ways to do it. You don't always have to replace the outdoor unit, but a good place to start is to take your acid test, see how bad that burnout really was before you go condemning the entire unit.
Steve and I were talking about this the other day too, and I think we've all seen burnouts where, you recover the refrigerant, you cut it open, it's almost like this sludge, like mud, this falls out. But I think what I told Steve last week when we were talking about this offline is I think it's going to be very rare for one of our systems to actually burn out to that degree because we're sensing temperature at the hot gas discharge. And for that to burn out, that compressor's got to be racing. Those temperatures got to get really high. And I don't think maybe I'm wrong, but I just can't think of a scenario where that temperature would get, I think it's 240 degree discharge line. It gets it and it shuts off. So I think there's protection against that. I just wanted to get that out there. I don't think this is very, very common or it's a possibility even, but
yeah, there's a lot that goes on that prevents our compressor from running if it detects issues along those lines. Yeah,
but to Steve's point, and moisture is bad, and I was shocked. I just found this out recently. I always thought that an evacuation of a system was a requirement. I just found out recently it's not a requirement anywhere by anyone. We put it in our manuals that it's a best practice, but now Don Gillis was on a couple of weeks ago talking about the A2Ls, and what's now what we call a best practice will be a requirement with the A2L. So finally, an evacuation will be a requirement. It should have been a requirement all along, in my opinion, but that's going to help prevent any of that. And, with all the strainers that we have, there's no filter dryers in the system. Brazing, flowing nitrogen while you're brazing is now a requirement too with A2Ls. So it's a best practice. It should be done because that's what's going to clog those strainers.
You may actually even see in our install manuals different applications of an evacuation. If you look at a P-series process of evacuation versus like an MXZ branch box style system, there are different explanations. The way I've always trained and the way I've always behaved in a van was to do the triple evac, which you'll find in our MXZ install manuals. There are some other applications of how we want the evacuation done, but to cover your butt, I would always say do that triple evac the way it's done in that branch box MXZ outdoor unit system, because that's that triple evac where we get that 4,000, 1,500, and 500 micron pull, making sure we have no moisture in the system.
Yeah, and I know a lot of guys are going to say, well, it's a new system, it's a new indoor unit, a new outdoor unit, a new line set. You don't really need a triple evac. I've heard people say that. I'm going to respectfully disagree with that because you have to put a lot of faith that everybody on that job and everybody's done this right. But, we talked about line sets. We've all seen those nightmares where the line sets, we find dust and pebbles and sand inside our compressors because the people are dragging these line sets through the yard and through the grass. They throw it in their van. So I would just do it. There's no harm in doing it. And if everything is clean and brand new like you think it is, then a triple evac is not going to take all that long at all.
Yep. Yeah, that actually,
especially after you've done a 600 psi pressure test, triple evac should go really easy.
Yeah, absolutely. Yep. And I bring that up in class a lot when it comes to protecting your line set, because you can do everything right on a job, but how often are you going back to your warehouse to grab line set that was left over from the job before, and that was left open for months until you had your next install? And so even protecting that line set in between jobs is paramount because you can get all kinds of stuff in there. I worked on AC, oil, gas, generators. I had speedy dry and odor absorbent powders. And if I didn't protect my line set when it was in the van, just transporting it to and from the warehouse, things were going to get inside there. And I could have done everything perfectly on my next job, but the dust and the moisture and the dirt is already in that line set. So protecting it at all times, not even just on the job, is important.
Yeah, just throwing tape over the end of it. If you say you're running a line set and you plan on coming back to that job site and you're not finished with the piping yet, just putting some tape on the end is not going to cut it. You're going to have to flatten the end, braze it shut. It could rain in between that time that you return to that job. That moisture is going to get in there. Lines that are sticking up through a roof, always flatten that end, braze it shut, be on the safe side, keep it tight, keep it dry, right?
Keep it tight, keep it clean, and keep up with your line lengths as well, too, especially when you're doing a multi-zone. So let's picture this. You got a branch box in an attic or in a basement, and you're going to run 5 zones to it. Maybe you got 2 branch boxes, you're going to do, 8, Just keep in mind, when you're running roughing in those line sets, label both ends. So you know that you're connecting to the right port along with those wires. Run the wires with them. So you know because we talked about cross wiring. Well, cross piping is the same thing.
Oh, yeah.
You want to make sure you know which one they're going to.
Yeah, I also want to talk about brazing with a low-pressure nitrogen sweeping through the pipes. So this is also another important part of the installation. If you are going to do any type of brazing, that you're flowing a low pressure 1 to 3 psi of nitrogen through the piping to remove any oxygen within that piping that will cause that scaling, that oxidation that builds up inside the pipe. Whatever you see on the outside of the pipe when you're brazing, that flaking, that's happening on the inside of the pipe. And if that gets into our strainers, gets into the oil and contaminates it, that's a huge problem. So make sure you're sweeping nitrogen at all times. Making quality flares, quality leak-free flares, huge on that system, right? And this means using the correct tools, whether you're using an old mechanical flaring tool, handheld flaring tool, or you're using some of the newer motorized flaring tools. The name of the game is to make consistent quality flares and
flare
make sure
gauge. I'm a big component on using a flare gauge.
Yeah.
Flare gauge is great, right? Juan had a motto that he used with the flare gauge, and I forgot what the heck it is, but if the flare slips through, it's too small, right? And if it doesn't meet with that inside edge on that flare gauge, it's too big, right?
Yeah.
I mean, we're not going to be able to force that on there.
Well, it's getting big in the industry now. Have you guys? I can't forget the proper term, but it's like a purple plastic gasket they're putting on flares now.
Yeah, so they're called either flare seal. Sometimes they're called flare tight.
Yeah.
Yep.
Yeah. So they're using that, and I instruct guys do not use that because over time the plastic can deteriorate and all that can go back into our system and strainers and our compressors. So again, just like Steve said, using the right tools to get the job right. And the biggest one, you can do a great flare, but if you don't torque it right, you're still going to leak. So
yeah.
Look, I just want to say one thing. We're talking about a lot of things, and I think there may be some people listening and saying, you know what, I'm not going to do that. I've been doing this for so long. I haven't had any problems with it. You always hear that, but this is the way I've always done it. It's never been an issue. Well, when it is an issue, it's going to make you look bad. It's going to make the equipment look bad. You're going to have an unhappy customer, and an unhappy customer is going to call 100 times more people than a happy customer will, and the word is going to get around. But you want to do it right. You're going to go through the expense. You're going to charge good money for installing any piece of equipment, no matter what it is. You want to do it right because your name's going to be on there. You want to do the load calculations. You want to make sure the ductwork is right. Check everything else. The proper wiring. Connect everything right. Do the proper piping. Keep it tight. Keep it clean. Do the triple evac. Braze. If you are gonna braze, and I think less and less people are brazing because different cities are requiring different things. So, and maybe there's other non-braze connections you're going to use the right flaring tool, and all of these other things that they make and they come up with. If you do things the way you're supposed to do it, you don't need those things. They advertise this stuff that you can put in a system and it's going to find the leak. But if you do the right workmanship, if you do it properly, you're not going to need that stuff. Stay away from it.
Yes. A properly made flare doesn't need anything but maybe a little refrigerant oil.
Yeah.
So everything else you can use, but just know that you don't need it. Proper flare doesn't need it.
Now, pressure testing, right? We're going to pressure test. Mitsubishi recommends that we pressure test up to 600 PSI. Now, a lot of contractors say, well, why such a high pressure? Well, think about it. Our units in heat mode can run as high as 500 PSI. And especially with a hyperheat system, they can run pretty high in pressures. So we want to make sure that we get that full 600 PSI in there to make sure there's no leaks in that system, and then perform a triple evacuation. And triple evacuation just ensures that we're getting all non-condensable gases, moisture out of the system, and we're doing it, I think, doing a triple evacuation gets you down to 500 microns much quicker than one single evacuation.
You know what I hear a lot, Steve, about that pressure test 600 is a lot of guys in my classroom, they're afraid to go up to 600 PSI. And
and a lot of that has to do with blowing. They're afraid they're going to blow through one of the shutoff valves.
Yeah. So I at that point, I have the guys go look at the data tags in our unit, because it will say what our design high-side pressure is. Actually 601. 601 PSI. That's what they're rated for. So I showed them that, and they're like, okay, that makes them so. Or they don't have regulators that go up to 600 PSI. That's the other half of the battle.
One thing that happened to me, guys, and when you're doing the 600 PSI pressure test, I replaced the condenser, and so I pressurized to 600, and within minutes, it was down to like 400. I checked everything, and I couldn't figure out where the leak was. I brazed something in, so I soaked that. I even went through and checked all the existing heads to make sure maybe there was an existing leak that I had missed before. What I found out was that being that when you energize our LEVs, they go to minimum position. So I was just putting in pressure on one side, and it wasn't a leak. It was just equalizing. But that took me for that point. That kind of freaked me out for a little bit. I couldn't find my freaking leak. And so, so you got to be mindful that either add from both sides or generate or open up those LEVs with using maintenance tool.
Yeah, once the system's open, you can also hit, pockets of refrigerant that may still be in that outdoor unit, and you'll have a similar effect too, where you'll put pressure to the system and then it'll slowly drop, and you'll actually hear it in the outdoor unit. You may even hear that liquid moving around a little bit. You're realizing, okay, things are moving around still. You might not have gotten all the refrigerant out of the accumulator or something like that. So,
pressurizing from both sides, I think, is a good practice, in my opinion.
So once you've done all that, you've kept your system clean, tight, and dry. You've got nice, tight flares. You've done your pressure testing. You've done your triple evac. Now it's time to add the correct amount of refrigerant, right? Make sure that if on M series, if you've exceeded 25 feet with an M series 1-to-1, that you're looking on the name tag in the installation manual and find out what the ounces that you need to add to top it off, and that you want to get as precise with that charge on that system so that the system runs at peak performance.
Data tag has all that information right there at the outdoor unit.
Yeah, and keep in mind MXZ branch box or Smart Multi, the Smart Multi branch box system. The refrigerant that comes with that system is just for the outdoor unit. Mm-hmm. It does not account for any piping added to it. It's the only system that's different than all the rest. So you're going to have to do your refrigerant calculation using the install manual, using Diamond System Builder software to figure out what your additional charge on top of what's in the outdoor unit, what you need to add. All right, so let's move to number 4, Bryn. Leveling units, using benders, properly supporting indoor and outdoor units. And I'm going to add something to that. Clean up after yourself.
Yeah. So the reason I wanted to add this one in here is because there are some things that can go wrong with the install, which we covered. But there's other things that make a good installation and what separates them from a poor installation or maybe just not the best installation is things like having a leveled outdoor unit, whether you put it on a stand or you put it on a bracket. What does it look like? Especially in the residential side where you have homeowners that are going to be looking at this every day for the next 10, 15, 20 years. How aesthetically pleasing is the install? How proud are you that your name is on that install? So I'm a huge proponent of taking your time when it comes to making sure your line set looks nice and neat and uniform. When we're talking about ported units, you may have, 6 different lines going into that outdoor unit or 8 different lines going into that outdoor unit. Are they all kind of at the same angle? Do you use a nice, clean bend to get onto that adapter? Because if you don't, and you're just kind of running line behind the unit, it starts to look like this octopus unit, and it's just not very aesthetically pleasing. So I'm a huge proponent of using benders. I've actually seen some installs where they use Unistrut on the outside of the house to make sure that everything is nice and straight and uniform, and it looks phenomenal. I mean, it makes a huge difference. It's going to work exactly the same as the one that was put together poorly. It just looks so much better. Something you can take pride in.
So that's just because they took pride in that work, right?
Yep.
That's where that narrows down to right there.
Yep. And then leveling units, right? So obviously for functionality reasons, the unit needs to be level. Safety reasons, it needs to be level. But again, imagine walking up outside of your house every day looking at your outdoor unit and it's got a lean to it because you didn't use a pad or you didn't shovel out underneath that pad. These are all things that to me are really important because you don't want the callback in 6-8 months when you didn't do the proper work to level. And now you get there, refrigerant's flowing through the system, and the thing looks like it's about to wash away from the water that came underneath it. So these are just things that I find make a good installation and separate them from poor installations. And to me, is really important as far as a common mistake that's made is I know we're all in vans, we're out there, we're trying to get jobs done, we're rushed sometimes to do things, but remember that your name's on it and take pride in what your units look like.
Clean up after yourself. All the little bits of wires, pieces of Armaflex.
Yep.
All of that goes a long way when you clean up. You have nice, clean installation. Customer's going to love you for it and refer you, right?
Yeah, it's got to look nice because at the end of the day, if it could be the best piece of equipment out there, it could work great, it could be super efficient. But if it's leaning to one side and it just doesn't look good, that's all anybody's going to see. Mm-hmm. And that is a testament to your work. So it's got to look nice. We talked about this just before we started with tune-ups. We used to send people to go to tune-ups. They'd clean out a furnace because what needs to be cleaned? The burners, the heat exchange, that's what needs to be cleaned. If it's got dust on it, it's not going to affect the operation of the furnace. But when the customer goes down to their basement, that's what they're going to see. It's covered in dust. The guy didn't do anything. He didn't clean anything. So just go that extra mile.
Not to mention it will increase your callbacks. So if a customer does have a concern and then they go up, let's say you've got a multi-position air handler in the attic and you ran flex duct all over the place and you didn't secure it and you didn't make it look nice and neat, they're going to go up there because they think something might be wrong. And when they see it look like a mess, they're going to be much more likely to be like, there's definitely something wrong. Yeah. They didn't take their time. They didn't care. If it looks nice and neat, it's nice and clean, they'll have more confidence in that installation. You may not get those non-service calls, service calls that we've talked about before.
If those guys left trash behind, what else did they do?
Yep.
It's that trust factor.
Yep. So good talk, guys. And for those listening, I just want to mention this. There's a new feature we have. So if you're most people, I think 90% of the people are going to listen to this podcast on their phone. But if you look on your phone and you look at the episode description, just above that, it says, send us a text message. So you can click on that and send us a text message. It comes to us. We don't have the ability to text you back on that, but we'd love to hear from you. How you like the show, ideas, topics that you want to hear, questions that you may have. We usually do take, I would say, 87.4% of the suggestions we get, we listen to. And
87.4?
Roughly. Roughly.
Okay,
all from the same one person that sends us emails.
Yeah, Nick in Hawaii. You know what? We have to have Nick in Hawaii on the show because he emails us, and he was actually the first one before we told anybody. But I turned on this feature like on a Monday at 2.
Yeah, and he sent hi.
Yeah, a Monday, at 3 o'clock, he sent us a text. So the guy's a super fan. Well, we got to get him on the show.
Yeah, definitely. And if you're wondering, where do I find installation manuals for Mitsubishi heat pumps? MyLinkDrive.com. Service manuals, installation manuals, data books, engineering manuals.
Metals.
Sign up for training. If you want to sign up for training, go to MitsubishiComfort.com. Click on 4 Pros, click on training, and look at a calendar of training events that we have across the country. And sign up today for live in-person training.
And if you have a flip phone and don't have the ability to send a text, you can send us an email once you get home to your iMac or Macintosh. You can actually send us an email at the Metis Tech Show at hvac.mea.com.
Oh yeah, I remember sending texts with flip phones. It took a little longer. But
T9.
I remember sending texts to a pager.
Yeah,
That's old
yeah.
school.
yeah.
That's old school. Bryn's like, I don't even know what you're talking about. But
Now I had the pager where all you'd get was a phone number. You wouldn't know who it was. You just had to call them up, find a phone, because you didn't have a phone, and you have to call them up. Who's this? This is Paul. And then the upgrade to that was a text pager. They'd send you the message with the phone number, everything else, and now look at us. I have people. I was the last person I know to get an answering machine. Back when I had answering machines, I didn't want people to call me when I was home, never mind when I wasn't home.
yeah, we were very resourceful back in the 90s with pagers. We were able to turn phone numbers into inappropriate texts to a pager. So,
Oh, yeah.
yeah. So
It's like when you
anyway,
learn a new language, the dirty words are the first thing.
so the next time I'm in the West Coast, Sergio, you're gonna bring me to a place that has birria tacos.
Yes.
Oh, yeah.
Media.
Like
I'll
birria.
do one better. I'll make you some.
No,
Oh, there we go.
that's okay.
Oh.
We'll just, you can just
Oh,
take us to a place.
Hey, we have our instructor meeting. We have our instructor meeting coming up in August. So don't be shy.
Yeah, we'll grill out.
Yeah, the hotel room has a stovetop and some pans, Sergio.
Yes. There you go.
All right, we'll see you guys on the next one.
Take care.
See you guys.